Hello students, this video is on Unit 1, Lesson 7 for segment partitions. We're going to be talking about a graphical method in order to take a segment and break it down into two partitions, two parts that are in a common ratio. You can see in the example here, this is a segment that was broken down into two pieces, a 7-part piece and an 8-part piece. Here you have a segment that was broken down into 4 different parts, 1 part here and 3 parts here. We're basically going to be talking about what to do when the question asks you to partition a line segment into 2 different parts. Let's take a look at the learning target. According to the target, we're going to be able to partition a segment into a given ratio using slope and identify the point that creates the partition. So we got 2 different things that are going on here. One thing is very procedural, being able to split a line segment into 2 different parts, and the second part is very algebraic, identifying the point that creates the partition. And we're going to be showing you the first method today. In the do now, it tells us that we're talking about ratios, and we're also talking about slope. You remember both of these things from algebra, so pause the video, try these 2 out, and see if you can get them right. All right, for this first problem, it asked us to determine the number of boys and girls in Mrs. Mariano's class, and it gave us some information. It told us the ratio was 3:2, and there were 25 total students in the class. If you remember from when you took algebra, you should remember that when you get a ratio like 3:2, that kind of thing, you're able to break it down algebraically as 3x and 2x. There's some common factor that you're multiplying by in order to get the actual numbers from the ratios, but you don't know that number. So all we can say is there's 3 parts of the first thing to 2 parts of the second thing. And remember, we're asked to determine the number of boys and girls, so we're going to circle that. That's how you annotate a problem. Once we figure that out, we can set up the equation to say, well, boys plus girls is equal to the entire class, 3x plus 2x is equal to 25, and then solve that to get x equals 5. Then finally, we can take that 3x and that 2x and substitute the 5 back in there. 3 times 5 is 15, 2 times 5 is 10, and 15 boys and 10 girls do make up the entire class of 25 students. All right, for this next problem, you were asked to find the slope, so we identified x1, y1, x2, y2. Put it into the slope formula, which is y2 minus y1 over x2 minus x1. Substitute, do a lot of evaluation, and get the slope is equal to -2 divided by -1, which is the same as +2. So you should have gotten the slope is +2. Moving on to the actual lesson. We're talking about ratios today, and a ratio is a comparison between 2 quantities. So if you're looking at these blocks, I can see 2 different cylinders here and 4 different cubes. We can express the number of cubes to the number of cylinders by expressing both numbers in a ratio. So again, we're talking about the number of cylinders as compared to the number of cubes. We have 2 different cylinders, this first one and this second one, so that's 2 in total, and we have 4 different cubes, 1, 2, 3, 4. So what we can do is say, well, for every 4 cubes, there are 2 cylinders, right? So 4 cubes to 2 cylinders. We can express it as 4:2, 4 to 2, or 4 divided by 2 in a fraction form. This is a little bit more uncommon, but we can think about a ratio in terms of a fraction as well. We can tell from the ratio that there are 6 total objects, 4 to 2, right? 4 plus 2 is 6. And we can also simplify a ratio by removing common factors. If I take the 2 out of the 4 and the 2 out of the 2, I can reduce it down to 2 to 1. So you could read this as, for every 2 cubes, remember the first number was cubes before? For every 2 cubes, there's 1 cylinder. And that's true, because for every 2 cubes, like these 2 cubes, there's 1 cylinder. And then you can count the other 2 cubes, and then you can recount, or count again, the second cylinder. So that's how ratios work. For every this many parts, there's this many parts. When we're talking about ratios in terms of a line segment, we can identify a point on the line segment that partitions it. So for example, in this line segment, MN, P is the partition point, which means it splits the line segment into 2 different parts. It splits it into the 5-unit part and the 2-unit part. As you can imagine, the entire length of this line segment is 7 units. Which should make sense to you because there's 5 units on the left-hand side of P and 2 units on the right-hand side of P. And we're being coy and cagey when we say units because we don't know whether it's inches or centimeters or light years, whatever it is. But the idea is that there's 7 total units and there's 5 on the left and 2 on the right. We can express this ratio in terms of, well, frankly, a ratio, 5 to 2, meaning there's 5 parts on this side and 2 parts on that side. The graph method for finding out the point that partitions a line segment is actually fairly straightforward. When you graph a line segment, you can tell that it's got several slopes between each of the individual endpoints. Like from here, point C, to here, point D, there are actually 4 different slopes. We go up and over, 2 over 1 once, then 2 over 1 twice, 2 over 1 3 times, 2 over 1 4 times. We've done it 4 times, which means there's 1, 2, 3, 4 parts. Now, if the question asks us what point splits it into the ratio of 1 to 3, that's pretty straightforward. We just need 1 part that's on the left-hand side and 3 parts on the right-hand side. That would be this point right here. That point, of course, is point P. We call it point P because it's the point that partitions the line segment. And we can identify its coordinates just by graphing. And here is the first instance of the geometry teacher's dilemma, which is sometimes students like to draw lines on their paper without using a straight edge. If you don't use a straight edge for this type of problem, you won't be able to identify how many slopes there are, and you definitely won't be able to identify where exactly that partition point is, so please use a straight edge. Your student ID, your Metro card, a ruler, $20 bill, whatever you got. All right, in this model problem, it tells us that AB is a line segment, and it tells us that point A and point B have these coordinates. Now it's asking for the coordinates of P, and we know that P separates AB into the ratio of 1 to 3. Well, let's take a look at what AB, the segment, actually looks like. Okay, and we've graphed this. We've said A is here and B is here. So what we're going to try to do is figure out where P is. And keep in mind, it's partitioning AB from A to B. We're talking about a directed line segment in this case, in the ratio of 1 to 3. So wherever that P is going to go, it's going to have 1 piece that's on the left-hand side and 3 pieces on the right-hand side. In order to figure out where those pieces land, usually what you'd have to do is find the slope. And let's find that slope right now. You should remember what the slope is from the warm-up. If I give you 2 points, all you have to do is identify x1, y1, x2, y2, and then substitute them into that slope formula. So let's do that now. All right, once all said and done, we can figure out the slope is -2 divided by 3. Now keep in mind, that means for every 2 we go down, we go 3 horizontally. So let's actually show that graphically. For every 2 points we go down, we go 3 horizontally. And this should make sense to you because the next point in the line segment is right here. I can keep doing that and I'll show you what that looks like here. So you can see that every time I went down and over by 2 and 3 respectively, I got to another point on the line segment. That's the idea behind lines, right? They have constant slopes, which means they continue to go straight. They don't deviate from that. One thing that we can do with this is say, I don't know, partition the line segment. Keep in mind, it says the ratio is going to be 1 to 3, which means I need 1 part of the line segment to be on the left-hand side towards A, and I need 3 parts of the line segment to be on the right-hand side towards B. Well, look at that. We have 1 part that's here, we have a second part that's here, we have a third point that's that's here, and a 4th part that's here. So we can split them into the ratio of 1 to 3 just by finding the point that splits it into 1 part to the left and 3 parts to the right. And guess what? That point is right there. Now, the question does ask us to find the coordinates of P. We've already identified that this point is P. The coordinates must be written down now. So we can label them by counting out the boxes on the graph and then say the coordinates of P are -2, 2. Easy enough. Next problem, I'd like you to try this out by yourselves. You graph the points. You try to find the slope of the line and see how many slopes are going to take you for 3 parts on the left side and 4 parts on the right side. Pause the video, try this one out. All right, so you should have gotten that the slope of this line is 1 over 2. That's pretty elementary math. And you should also have graphed the line segment, of course, making sure that the points have labels, like these labels. Anyway, what you should have done already is you should have used this slope, which is 1 over 2, to say, well, every time I go up 1, I go horizontal 2. Every time I go up 1, I go horizontal 2, and so on. And as you watch this pattern, you should be able to see that this line segment is being split into several different pieces. The number of pieces is going to be equal to the number of times you do this slope method. And as you should probably be able to guess, the number of pieces is also going to add up to the same sum as the pieces in the ratio. This is 3 to 4, right? I got 1, 2, 3, 4, 5, 6, 7 pieces, which makes sense because 3 plus 4 is equal to 7. Now all we need to do is find the point that splits it into the ratio of 3 to 4. Starting from A, we need 3 points, or 3 parts, I should say. So we go up 1, 2, 3. This point is our winner. This point is going to split the line segment into a ratio of 3 on this side and 4 on this side, right? Because there are 3 slopes going from here to here, and there are 4 slopes going from here to here. Of course, the question is asking us to find the coordinates of P, so we need to, of course, write down those points. Or, I should say, write down those coordinates. So again, I'm just going to count it out on the graph. I go backwards by 3 horizontally and downwards by 6 vertically. It's not necessary for you to write this part, but it is essential that you write out the answer. The coordinates of P are -3, -6. All right, this was the video on using that graphical method to partition a segment. The next video will be about using a different method to partition a segment. Specifically, when you don't have a graph in front of you, you can use an algebraic method. All right, folks, good luck studying.